So the next topic in enthalpy is looking at bond enthalpies. And remembering from previous video, enthalpy change is the energy difference between all of the bonds in the reactants compared to all of the bonds in the products. And the energy needed to make or break particular bonds aren't known, and they are provided for you in the data booklet. And these amounts of energy are called the bond enthalpies, and they're on page 10 in the data booklet, and they have units of kilojoules per mole. They have, units of kilojoules per mole. Now, when it comes to bond enthalpies, there are two tables on page 10. For bond enthalpies. On the left-hand side, there's ones that are just called bond enthalpies, and those are for bonds that can be exactly calculated experimentally. So, for example, the hydrogen-hydrogen bond can be calculated exactly because there's a molecule that just has that bond in it. The oxygen-oxygen double bond can be calculated exactly because there is a molecule that just contains that bond. And the same for nitrogen, the same for hydrochloric acid, HCl. Anything where two atoms are bonded to one another, you can work out the exact bond enthalpy. However, there are other types of bond where the enthalpy is not always going to be exactly the same and will change depending on the environment. And so an average or mean bond enthalpy can be determined, and those are given on the table on the right-hand side. So types of bonds that don't have a permanent exact value are things like a carbon-hydrogen bond, a carbon-carbon bond, or a carbon-oxygen double bond. And so those have mean bond enthalpies. Now, we can use these bond enthalpies to work out the overall enthalpy change for a reaction. We can use this method for combustion, but it's usually used for other types of reaction. Now, when it comes to breaking bonds and forming bonds, whenever we break a bond, we need to put energy in. So breaking bonds is endothermic, and the delta H value is positive. When a bond is formed, it actually releases energy. It might seem strange, but when a bond is formed, energy is released. And so anytime a bond is formed, that process is exothermic, which means that it has a negative enthalpy change. Now, whenever we take a whole reaction into consideration, we think about all the bonds in the reactants being broken. So that's an endothermic process. And all of the bonds in the product are being formed. So that's an exothermic process. The overall reaction enthalpy is going to be the bond enthalpy of the reactions, positive, minus the bond enthalpies of the products. So if we know all of the bonds that are present in our reactants and all the bonds present in our products, we can use delta H equals reactants minus products to determine the overall enthalpy change of a reaction. So we're going to look at two examples. So our first example, we have hydrogen combusting to form water. And what we have is on our reactant side, we have two hydrogen molecules. So that means we have two hydrogen-hydrogen bonds. And we have one oxygen molecule, so that's one oxygen-oxygen bond. On our right-hand side, when we do our multiplication, looking at the table, a hydrogen-hydrogen bond has a value of 436. So when we multiply it, we get 872, and oxygen double bond is 498. And the total is 1370. Just add them together. For our products, we have two water molecules. Each water molecule has two OH bonds. So we have a total of 4 OH bonds and nothing else. each OH bond has a value of 463. So when we multiply that by 4, we get 1,852. And our overall delta H is reactants minus product, so that's 1370 minus 1852, which gives us minus 482. And it's negative, which means it's exothermic, which is what we would expect because it is a combustion reaction. Now that, because two hydrogens are involved, is not the enthalpy of combustion for hydrogen, but it would be 2 times the enthalpy of combustion for hydrogen. Our second worked example is another type of question that you might get, which involves molecules where all the bonds are drawn out. So for hydrocarbons, this is quite common, and it can be quite a long process to identify all of the bonds. So what I've done is I've actually coloured in all the bonds as I go through them to help it make it clear. So we're going to look at our reactants first. In our reactants, we have 2 types of bond. We have got carbon-hydrogen bonds and we have got carbon-carbon bonds. So we have got 6 carbon-hydrogen bonds, which I've highlighted in green, and we've got 1 carbon-carbon bond. And that's it. On our right-hand side, we've got 2 different types of product. We have got the one that contains carbon and hydrogen, and then we've also got the hydrogen molecules on their own. So you have to consider all of them together. So in our product, we have 2 carbon-hydrogen bonds, and then we've got 1 carbon-carbon triple bond. Now it's really important that you pay attention, because in the bond enthalpies, a carbon-carbon single bond has a different enthalpy than a carbon-carbon double bond, and again a different enthalpy from a carbon-carbon triple bond. You need to make sure that you pay attention to how many bonds there are between the carbons, not just how many carbons there are. Okay? And then finally, we can't ignore our other molecules. We have got 2 hydrogen-hydrogen bonds. So it's identifying all of the bonds, and then on the next slide, what we'll go through is breaking down all of the multiplication and addition and subtraction we need to do. So we had 6 carbon-hydrogen bonds and 1 carbon-carbon bond. When we look those up and do our multiplication, we end up with 2,820 for our reactants, and then for our products, when we do all the maths, 2 times 412, 1 times 838, and 2 times 436, and add them all together, we get 2,534. When we do our final stage, reactants minus products, we have 2,820 minus 2,534, which gives us 286, positive 286. Now, when a process is endothermic, you don't have to have the positive on it to get the mark. However, getting used to always having a sign for positive for endothermic, negative for exothermic should help you remember that when it is exothermic, you need to put that negative on. Okay, so technically for this question, if you'd just written 286, you would get the mark. But if it's an exothermic reaction, you need the negative on there. So that was the final part of enthalpy relating to bond enthalpies and how to calculate them.